Hey, did you miss me? So, on this one, we're going to draw a detailed drawing of our piston and rings. The skirt, the ring lands, the compression, and the oil control rings. So, today, we are going to learn some terminology here. Okay? So this down here, this part down here is what's called the skirt. Okay? Almost every piston out there will have this piece here, which is basically it's a skosh smaller than the actual cylinder wall. It will almost always on the side where the pin goes through be caved in like this part way. Some are slightly different. I'll show you an example here of another one in a minute out of a regular car engine. Okay. Of course, we call this piece here, that is just our crank pin. Okay, that's the pin that holds it in. The wrist pin, we call that. Okay, and then here we have these top two rings are our compression rings, and then the bottom one is our oil control ring. Now, pay attention to this guy. That is kind of a springy deal in the middle there, and then these are two separate rings that are very thin that actually scrape the wall. They like bring the oil up the wall, and then they scrape the excess off. Very similar to a spatula, if you will, or something where it just scrapes the pan clean. Now, you'll notice that I got a ring gap here. Got a ring gap here. And then on my oil control rings, you see there was one there and one right there. Typically, we don't want to line them up. So when we go to put this back together later, we're going to want them to be staggered, especially the compression rings. You want them staggered. You would not want this to happen. When you put them together, you would not want this to happen. Even though they're compressed together inside the engine, you wouldn't want them right on top of one another. So if anything is going to get past, it's going to have to get past, make a turn, come over here, and then make another pass, and then get out. It's going to be really hard to pull that off. So I'm going to let you stare at this for a minute. You're going to draw me a picture of this as part of your assignment this time, and send it to me. Okay. The top shouldn't be black, probably like that black anyways. There it goes. So you're going to draw that picture. This pin, the wrist pin, only comes out one way on this kind of cylinder. This side here is solid. You take this little clippy-do out of here, and then you can push the wrist pin out this direction towards you. Okay? I'm not going to take it apart. There's no reason to. You can see there's a little bit of striations here. Ooh, clicky, clicky, clicky. Do you feel that? Ooh, that's some scoring there, friends. Some scratching. I'd say it's a little more than a score. It's more of a scratch. Okay, maybe a little bit of scoring, but it's more of a scratch. On this side, yeah. Okay, we're going to be measuring that in a minute, so just be aware of that. Now, I'm going to gently take off the top compression ring. I could take them both off if I wanted to, but there's really no point to it. They look very similar. I'm just going to demonstrate one thing to you. Now, back again, in the good old days when things were cheap, okay, we would have you do this individually, but what ends up happening is kids end up breaking them, and then they're really expensive for what they are. Okay, so I made a little mark. Usually I use paint pen, but I didn't have one sitting next to me, so I did it with a Sharpie. What you're going to want to do is you hone in on, if I can zoom in there a little bit. Focus. Focus. Focus on it, you hippie. You see that? It's kind of tapered. It's a little hard to tell perfectly. It's a little tapered to the ring there. Some of them will be, come on, focus. Well, piddly diddly. Some of them are more so than others. Again, here's the one out of our big engine that we took apart. So we're going to be using, again, you can see these are thicker rings, obviously. Obviously thicker rings. The oil control ring is built the same way, where that's kind of a springy deal with two teeny tiny little control rings on either side of that, and of course two compression rings. Now, very oftentimes the two compression rings are slightly different from one another, and so they'll be labeled. This is the top one, it's the second one down. These two look very similar. Pay attention if you're ever building an engine. Pay attention that they aren't different, or they are different. Pay attention to that. Parts for the big engine should be in Monday. So next week I'll start putting that engine back together, and we'll be recording that. So stay tuned. What I want you to do is when you draw that piston picture for me, look it up, and then what I'd like you to do is actually let's look at some piston rings here. Piston rings. I'm just going to show you some things here. What they look like from the side. And so you can see those ones there. They're fairly straight across. Let's see if I can find something that shows some taper to them. I'm just trying to show you what a picture of them looks like. It's not a huge deal. Just be aware that some of them are tapered and some are not. And that's why you always want to mark which one is the top one and which is the next one down. And so forth, because they're not always the same. Well, I'm tiring of this. Alright, so let's go back into the manual. And if you go back in the manual, we are going to be looking at compression. That is where rings will be, I believe. Let me see here. Minimize. Nope, I lied to you. It must have been under cylinder rings. Let's go look at that. There you go, rings and rods, you moron. Section 9. Okay, now, in this section 9, it will show you some pictures. Okay, removing the connecting rod. We're not going to do that. Now, removing the rings, you can do it with these fancy tools. Okay, that's possible to do it with the fancy tools. Or you can use just your fingers and get them off. Now, I don't know. It's possible to screw them up both ways. It really is. Okay? So, what we would do if we're putting in new piston in, or new rings in, the first thing we do is make sure we clean out these ring lands. Remember, the grooves are called the ring lands. Okay? So, to put this on, what the guy does is you just hook it in there on the one side, hooked in, see? And then you just walk it around gently. Whoop, and in theory, it just flops right in. Okay? Then what you want to do is you want to measure the ring land clearance. This is something that is a measurement that we do. This one's obviously too big and will not go in there. I didn't come prepared to measure that. I was just thinking about it just now. Here we go. Here's a 1.5 thousandths. Let's see if that's big enough. It is. It's like 1.5 thousandths ring gap, or ring land clearance. Okay. So remember, the feeler gauge is something we'll use a lot for these tiny little measurements. So let's work our way through section 4 here. Okay. You'll be again drawing me a picture, so make sure you're ready to do that. Okay. If you're doing this, you want to make sure your piston's completely clean. Any carbon out of the ring lands, they will not be good. We had a little slightly scoring, I think, there. That's what I would call that. It's not bad, though. I'd run it again. Then we're going to measure 90 degrees to the pin, about 1/4 inch from the bottom of the piston. Okay? So, again, we're going to measure that with a mic. So we're going to go from here to here, down in here somewhere, okay? So, let me get on that, and I'll tell you what the measurement is roughly here. Mr. Groom, it's only like 2.5 inches. No, you're wrong, pal. How do you know, Mr. Groom? Well, because I feel like our hole is something like 2.561 something or another. So I feel like that's not going to get the job done, sir, ma'am. Mm-hmm. 2.56 2. 5628, I guess. 2.5628. 2.5628. Wait, Mr. Groom, you read that wrong, you goob. Now, let me go back. Obviously, I made a little boo-boo. Now, clearly, I read my mic incorrectly. Let's go back and double-check that, Mr. Groom. What's wrong with that picture, Mr. Groom? What? Mr. Groom, that's too big to go inside the hole. That's right, you big ding-dong. So, that's how, and I kind of did that on purpose, kind of on accident. Clearly, if that were the case, that would not go in the hole, and we'd have a bit of an issue, yes? Mr. Groom, I have a problem with my engine. What's that? My pistons don't fit. Well, that's a problem, all right, sir, ma'am. There we go. That's a little more better-ish, you big dope. Goodness, what did I do wrong? I must have been crooked a little bit. 2.56. Oh. 5-ish. Which is about 1/1000th smaller than the cylinder, okay? So is that going to be a big deal? Is that going to be a measurement that I care about? Yeah, I think so, because think about this. If you have this, and then your piston was sitting way in here, your rings can only go out so far. You're going to have a lot of blow-by. You're going to have a lot of compression escaping, of course, burning oil too. Not okay. So again, it's just a little less, about 1/1000th of clearance. Probably somewhere in that ballpark. Yeah, somewhere in that ballpark. So we're pretty good there. Okay. Now, did all that. Cool. If it's more than 10,000ths, it's bad. We're good to go, friend. Okay. Refer to checking the ring end gaps. Okay, so to do that, and we're only going to do this with the compression ring because that's the only one I want to take off. I took it off, and then I'm going to take it. I put it back on. I'm taking it back off again here. Okay. So what we're going to do. What we're going to do is we're going to take this ring off the cylinder, like so, off the piston rather. We're going to stick it inside of the cylinder. See that? See that's crooked though? What I'm going to do is I'm going to take my piston, turn it upside down, shove it down in the hole, and that forces the cylinder, forces the ring to be in there straight. Okay? And as you can see, it sure looks like it's pretty close. Now, you can see right there, you see the ring gap right at the bottom. You see it? What I'm going to do is I'm going to measure that ring gap with my feeler gauges here. I'm going to start with 4/1000ths. See where I go from there. Well, there's 3. 3 is already in my hand. I'm going to try 3. Oh, it's way bigger than 3, Mr. Groom. It's way bigger, sir, ma'am, person. Oh, what about 4? Let's try 4. Yeah, oh, it's way bigger than 4, Mr. Groom. Let's try 8. 8's right here, Mr. Groom. Let's try that. Oh, dude, 8 will not go in the hole, friend. Oh, yes, it does. Mr. Groom gives him his glasses on. Let's go 10. Let's do 10. Yes, 10 goes in the hole. Ooh, doggy. Well, should you go big? I'm not going to. I'm going to go 14, dog. 14,000. Ooh, 14 goes in. Sweet. Where are we at? 18. 18,000. 18 just. Not quite. Not quite. So let's go 17. 17,000ths. Okay? So our ring end gap is... Oh, you didn't even get to see that, did you? I'm sorry, kids. Mr. Groom will try again. Here. Oh, you missed it, man. You didn't miss much, though. Here's the deal. 17,000ths. Ring gap. Oh, it goes right in the ring gap, Mr. Groom. That's a good fit. Okay? 17,000ths of ring gap. Now, we should check our ring end gaps. So let's see what it's supposed to do. Oh, cool. Check your ring end gaps. Cool. Table 1, page 8. Table 1, page 8. If your ring end gaps, we are aluminum cylinder bores. You see this? Compression ring, if it is greater than 35 thousandths, you need to get rid of them. I got news for you, friends. 35,000 is a lot. It's a lot, and you're about halfway there, but you're way good to go. Okay, so nothing wrong with those rings. We're gonna go ahead and reuse them. Come up here. Now, if you focus on this for a minute, these are some of the different what it would look like if you had different kinds of compression rings. Ours, they look kind of like this guy-ish. Okay. Notice that ours are not in any way cut like this or that or anything. Okay, so just be aware of that. Now, some Briggs and Stratton engines use a one-piece oil control ring where it just has these little pointy pieces that stick out. That's not how this one is. This is what ours looks like. It has this middle piece here, which is a spring of a deal, and it has two thin rings on it. Okay, that's what you're going to be drawing when you go to draw our end pieces. Ours look more or less like both of our rings look a lot like, well, not like this guy, I guess, more than anything else. The top two, and our bottom one looks like this guy. Okay. Again, not a great deal of difference between our two compression rings. Okay. And go ahead and put him back on before I lose him. Okay. Again, hook one corner. No, you can't see that. Again, hook one corner of our ring in right there. Get in the hole, you hippie. And I like to follow it around counterclockwise. There we go. Yep. Yay, and the crowd goes wild. What? Okay, anywho, there we have it. So, what else did they want us to do on this sheet? We're good, we're good, we're good, we're good. And we're good. Okay, listen. The right answer is this. If someone is asking you about anything to do with the rings, if there's any gap on a ring that is too big, the answer will always be what? Compression. You will lose compression, and you will burn oil. Okay? Now, what happens if the ring gap is too small? Not much on a Briggs engine here, okay? I'm probably not going to tell you much. These things are the equivalent of Mr. Groom, just easy going, don't care. Okay. But if you had that in a car that with a turbo, if you start with too small of a ring gap, okay, as the engine heats up and heats up and heats up, everything expands, and these rings will actually grow in length, and they'll come together, and they want to keep going together, and then they have to go either, they got to go somewhere. So what happens is they go up like this, and when they go up like this, boop, pops the top of the piston off, which is less than bueno. Okay, it's not optimal, to quote Barack Obama. Okay, so yeah, that could be a problem in a high-performance engine. In a Briggs, listen, man, they ran them at the factory. They're fine. They're not a big deal. I guess if someone were to like go rummaging around in the old scrap bin and go, hey, this ring's kind of fit, and shoved them on and they were a little too big, then yeah, that could happen. But that's not really something you run into. Normally, it's they get worn too much, there's too big a ring gap, and they're losing compression and or burning oil. Usually both. Okay? All right, that is sheet 4, friends. It's been good talking to you. I miss you. Some of you, not all of you.